quality assurance, quality control, and statistics. A lot of statistics we've been using can be utilized in doing sampling in terms of real life scenarios, such as the business, in the medical world, in the corporate world, in communications, in almost every facet of our lives. Because we can't look at everything, but we can look at samples, and as we've learned in this class throughout most of this semester, we can determine if that sample is a good representation of the population. And we do this also in determining quality. Now, we studied statistical process control 2 classes ago, but there are other areas beyond that, and I want to go through some of these. These are the 7 basic tools of quality, and these are used universally. Cause and effect diagrams, also known as fishbone diagrams, invented by a man by the name Ishikawa. It's also an Ishikawa diagram. Ishikawa was the name, a Japanese scientist and mathematician who worked under W. Edwards Deming. Check sheets, control charts, which we've talked about already, because this is histograms, which we've done earlier in the semester. A Pareto chart, which we'll cover. Scatter diagrams, which we've done with the X and Y plot, used for correlation basically, and stratification. Let's look at some of these. The Ishikawa diagram, also called the fishbone diagram, this looks like a fishbone, was built by Ishikawa to show the potential causes of a specific event. And originally it was used in manufacturing, the 4 M's. He said all problems in manufacturing can be attributed to one of 4 areas. Actually 5 now, Methods, machinery, manpower, materials, and management. Now, we group this to determine where to further explore. This doesn't give us a percentage or the severity of it, but it's a good starting point here. And we look at this, for example, methods. Maybe the problems we're having in manufacturing have to do with how it's being made, the process of it. Or the machinery could be worn out, could be the wrong machinery. Manpower. And this is not blaming the person per se. 99% of the time, manpower problems are either caused by a poorly trained hire or a lack of training. That goes back to management. Materials. Perhaps we got the wrong material. Suppose things are rusting out too early. We should be using steel, which doesn't rust, rather than iron. And then ultimately management, which manages all this. Now, what this allows us to do is brainstorm what the problems are and where to explore further. One of the problems, though, is it can become very complex very quickly. There can be many problems. So we're going to talk about that in a little bit, how to iron that out. But when we have an Ishikawa diagram, what we do then is determine where and why the problems exist with a root cause analysis. We ask the 5 whys. For example, a vehicle won't start. Why? The battery is dead. Why is the battery dead? The alternator is not functioning. Why is it not functioning? The alternator belt is broken. Why is it broken? It was well beyond its useful service life, not replaced. And then ultimately, the vehicle is not maintained according to the recommended service schedule. This is the root cause. The battery is dead is one thing, but it goes right down to if we would have been following the recommended service schedule, the battery would not have been dead. This is the root cause of the problem here. So when we do Ishikawa diagrams, we're not just addressing problems, we're trying to find the root cause, because the root cause can probably eliminate more than one issue we're going to learn here. Now, we got the 5 M's of manufacturing, as we talked about, and other areas of business and the industrial world, as well as the academic world, the medical world, many areas use other areas. In product marketing of the 8 P's, product, price, place, promotion, people, processes, and its performance. And to have a clear understanding of this, obviously you need experience in this. But let's look at some of the 8 P's. Perhaps the price is too high. Or, the place, literally the placement. I worked on some over-the-counter products, and if you're trying to sell something to a child, actually with a parent, when a child's with the parent, you want on the lower shelf. I once worked with a product for dry eyes we talked about before, and that is mostly elderly females, and elderly females are usually below 5'5". So when on the shelf placement, if it's at a 6-foot level, they're not going to see it. No wonder they're not going to buy it. And you have to pay for product placement. Perhaps the people, the personnel, and like I said, not blaming, hey, you did this wrong. Maybe they weren't trained properly in the first place. Or maybe even the performance. Maybe it's not doing what we said it would do. Service industry, surrounding supplier system skill. The point of all these are, you look at this to determine what are all the problems. And then from there we determine where should we address it first. One of the simplest ways to address it first is a check sheet. Now what I've got here is, we want to see where the problems are. And I've got here a check sheet of types of defects. It looks like in a motor assembly check sheet. And we've checked out how many problems there are. Supply parts rusted, misaligned welding, improper test procedure, wrong part. This could be an Ishikawa diagram. And now we're going to see the volume of it. And I've tallied how many problems each day there are over a 7-day period. It looks like they're closed Saturday and Sunday. And if you look, the biggest problem here is supply parts rusted. The second biggest problem, have down voids and casting. Those are open spaces in the casting, which is the metal as it's being poured to make a solid piece of equipment. So there are many problems here, but the biggest volumes are supply parts rusted as well as voids and casting. And then you look at the greatest number of days this happens. It's interesting. It's on Tuesdays. We don't know why these are happening. We know why supply parts are rusted, but now we know the severity of the problems. They're not all equal. And what we can do with this information is we can develop a Pareto chart. A Pareto chart looks like a histogram. It's a bar graph. But we prioritize from worst problems to the least number of problems. What I have here, let's suppose I'm looking at late arrivals of people coming to work. What is their reason for people being late to work? On the left, I have the raw number of late arrivals. On the right, it's the percentage of them. Now, I should say, no, on the left, it is the wrong numbers. And what I have here with the blue graph, and that's referring to what's on the left side, the number one problem is traffic. Number 2 problem is childcare. Number 3 problem in terms of order problems, public transportation and weather. Very few overslept, and then an emergency. So I look at this, there are 6 different reasons people are late to work. But when I look at the percentage, or a cumulative percentage we learned about earlier, between traffic, which is about 35%, and childcare, which is about 25%, 60%. 6 out of every 10 late causes are caused by traffic and childcare. And I'm wondering if they're interrelated, people dropping their children off at childcare and then running into traffic. And how do we address all the issues equally, or do we address the most severe issues? Well, you look at this, there are some large companies, Coca-Cola has it, I know Eli Lilly, the pharmaceutical company in Indianapolis has it, a lot of companies have it, they have, Chick-fil-A has it, they have on-site daycare. You can watch out of remote cameras your children in the daycare on-site. Well, this will reduce probably dropping a child off at daycare, as well as, even around traffic, you're not running traffic 2 different areas, from home to childcare, from childcare to work. You're reducing it. So by addressing this one issue with 2 issues with a solution, we've eliminated 6 of every 10 late points. Now, we look at this, and you'll see this almost anywhere. almost all the problems, you go from highest to lowest, 80% of complaints or 80% of problems are in 20, are only, the total problems are in 20% of the areas. And this is why it's not all equal. We have to address the worst situations first, worst in terms of volume. That'll take care of the majority of the problems. Let's suppose, I've got some data here of why people miss their medication in the hospital. And some medications are very important. You take it right on time, or it may have a drastic effect on the health of the individual needing the medication. What I have here on the left is the frequency numbers of why they miss medication, and on the right is the cumulative percentage. So when I add all the reasons people, or I should say, the healthcare workers have missed medication for an individual, they just missed the dose, number one time. Or, and then number two, wrong time giving to it. Number three, wrong drug. And number four, you overdose the person. Number five, wrong patient. You can read these. I have all kinds of issues. There's actually 430 individual issues. But when I look at this, dose missed, 92 out of 430. Wrong time, 83 out of 130. Wrong drug, 76 out of 130. 92 plus 83 plus 76 make up, and 59 to overdose, make up 80% of all the problems. If we address the wrong time, the wrong drug, overdose, or dose missed, those four areas, we will cover 80% of the problems with missed medication. We don't have to cover all of them equally. We have to address the worst few, and that's what a Pareto chart does. Now, another area we look at here is stratified sampling. There could be different subsets. We talked about in the very beginning of the semester here of how subsets may change compared to each other. And I said people of high income may vote differently than people from low income. People, males may have different purchasing than females of specific items. So we have to address this. Now, granted, we have to make sure it's random. But we do this to see if there is a difference. If there's a difference, then we have to address this. One of the most common examples I think about is hairspray. People think hairspray is traditionally for females. Well, hairspray is used by men as well. How we advertise to them may be two different groups. Maybe we have to brand them differently for males versus females. And that's why we do a subset. When we do stratified sampling, we're going to say, what do males look for in buying hairspray? What do females look for in buying hairspray? And then we address this. Another example with Alzheimer's. I worked with Alzheimer's drugs for several years. And no one goes to the doctor saying, I think I have Alzheimer's, you have a drug for me. 85% of the time, it's the adult caregiver, which is a middle-aged daughter, who also usually is married and has kids at home also. So we have to stratify. We don't just stratify people who have Alzheimer's. We have to address who's taking the person to the doctor, who is the caregiver, and if the caregiver is male or female, does that make a difference? Caregivers working or not working, that makes a difference. That's why we stratify these things to determine if there is a difference, and it tells us different strategies we have to follow. So I look at here, I've got different hospitals here from another country, and the total number of nurses. And I take samples of the nurses here. So basically, these are all the nurses population. If I stratify them, they're different groups. I don't know how they determine the green, the red, or the blue. And these could be nurses specialized in pediatrics, or nurses specialized in cardiac care, other nurses specialized in emergency. But what you see here is there's a lot more green than there is red, a lot more red than blue. So to stratify this, we have to make sure those groupings are the same. We better make sure we sample more green in there is red, and more red than there is blue. Actually, they're high due percentage. I've talked about before, if you're going to do polls of how people are going to vote in Georgia, and people often vote differently based on their race, based on their gender, based on their income. As I said, in the United States, I think it's roughly 61% white, about 10% African American, about 13% Hispanic. Well, you do not want to get equal numbers of groups. You want to make sure those percentages are reflected in your stratification. Otherwise, what you have here is a disproportionate sampling. Some have more power over others falsely, or some don't have enough power where they should be. You want to make sure you're quantifying this in proportion. This is a flow chart, another way to look at things. And this is, let's say, telemedicine for a patient. Well, is the patient known, yes or no? If the patient is not known, we probably need to see the follow the arrow to the left and going down here. They need probably face-to-face consultation. Patients known, we determine then, do we need to see them in person or not? Can it be done by a registered nurse, or do they need to be seen in person? And this saves a lot of time. A lot of times it may be a minor problem where you don't need to drive across town and wait in the waiting room, where people have other illnesses. But at the same time, you want to be careful to make sure you don't have something that really should be seen immediately. And that's what a flowchart does. It gives you all the possible decisions